All right, so let's go over this 6162 quiz, even though you did not take the quiz. There it is right there, 6162. This is review. This is review for your test. All right, this is stuff that you did. You were supposed to do, and we covered it. So even though it wasn't on the test, it's still going to be, even though we didn't have a quiz on it, I should say, it's still going to be on the test. All right, let me change this to red. Let me change this to 0.75 instead of 1. All right, here we go. It says, find the sum of the measures of the interior angles of a convex hexagon. A lot of weird words there, a lot of geometry words there. Let's look at the easiest one first. What does the word sum mean? What is it? In math, what does the word sum mean? You add them all up. That's right. Okay. Add up what? The measures of the what? Interior angles. It means the angles inside, right? The interior angles of a what? Of a hexagon. Now, convex is just like any normal. Don't worry about the word convex. That's nothing that you have to worry about. So we want to add up all the interior angles of a hexagon. We have a little formula for that. What's that? Zoom in. Can't see that? Is that better? All right. So we want to find the sum of the measures of the interior angles of a convex hexagon. Well, it's a simple little formula. And write down this formula. It's n minus 2 times 180. You remember that, right? Is it coming back to you? If it's not, watch the videos because we taught it. All right? So that's up to you. You need to do that. And you should be grateful. You shouldn't say, oh, I got to watch these dumb videos. You should be like, wow, Mr. Hamrick, that's so cool that you put that on YouTube because now I can go back and watch it even though I forget it or even though I wasn't there or whatever. All right? That's your response. That should be your response. All right, to watching the YouTube videos. All right. So what does that mean? What is the n? It's how many sides you have. That's right. So when they say this is a hexagon, how many sides does a hexagon have? Hexagon. How many sides? 6. Okay, you got to know those. All right, 6 sides. All right, hexagon is 6. What's 5 sides? Pentagon. What's 8 sides? Octagon. Okay, what's 10 sides? Decagon. Those are the ones that are really familiar. They're the ones that we use a lot. There's other ones, obviously, but they're the ones we use a lot. We use hexagon, pentagon, 5, hexagon, 6. 7 we don't use that often, but that would be called some people call it a heptagon or a septagon. I had a book that called it a 7-gon. They just put a number 7-gon. All right. 8 is very common. That's an octagon. 9, hardly anybody uses that. It's a nonagon. And then 10 is a decagon. So hexa, you got to know. All right. So if I give it to you on a test, it may not be a hexagon. It might be something else. But it'll be one of the common ones. It'll be either a pentagon, a hexagon, an octagon, a decagon. Okay. It's going to be one of those. So what do? We go n minus 2. So what is our n? 6. So we go 6 minus 2 times what? 180. All right, 6 minus 2 is 4 times 180. And that gives you, put in a calculator if you need to. You might be able to do it in your head. I don't know. Can you? Can you go 2 times 180? What's 2 times 180 in your head? 360. And what if you double 360? Can you double 360 in your head? 720. Okay. If you can't do it in your head, it's fine. Use calculator. Put in 4 times 180. Yeah. No, it's supposed to be equals. I just didn't. I just had them too squished together. Yeah, no negatives on this. So it's 4 times 180, which is 720 degrees. That's how you do it. Very simple. Okay? This one's very similar to what we just did. It says find the measure of each. Here's the key. Look, I even put it in all caps. Right? I put sum in all caps and I put each in all caps. So this time we're finding each interior angle of a regular. What does that mean for a polygon to be a regular something? What does it mean if it's regular? All the sides are equal and all the angles are equal. Very good. And we just talked about this. What's an octagon? 8 sides. That's right. So here, go ahead. I am, yes. All right, so an octagon. How many sides is an octagon? 8. So what I'm going to do, I want to find each of them. I don't want to find what they, well, I do actually, want to find what they all add up to be, but like this one right here, what if all the angles were exactly the same and they all added up to 720? What would I do? Divide it by what? Divided by 6, that's right. Everybody see that? So what am I going to do here? I'm going to find what all the angles add up to be, the sum, but this time it's an octagon. And then what am I going to do? I'm going to find that number and divide it by 8. Exactly right. So there's only one little extra thing that you have to do on this one that you didn't have to do on this one. Okay? So let's do what we did over here. N minus 2 times 180. So how many sides does an octagon have for the third time now? 8. 8 minus 2 times what? 180. That's 6 times 180. And that gives you 1080. 1080. But that 1080 is what all the angles add up to be. But I just want to find what one of them is going to be if all those angles were exactly the same. So if all those angles were exactly the same, and there's 8 of them, right, because it's an octagon, how do I find out each of those angles? Divided by 8, that's right. Put that in a calculator, and you get 135. So each angle of a regular octagon is 135 degrees. All right? Thank you. What do you see in everyday life that's a regular octagon? Probably every single day you see it, and that's a stop sign. And it's a regular octagon. So if you were, I wouldn't suggest it, but if you were to go to a stop sign and take a little protractor. I always get those two words mixed up. If you take a protractor, right, and you put it up to an angle on a stop sign, any stop sign, doesn't matter how big or how small, you're going to find that each angle is what? 135 degrees. I actually used to work with stop signs every day of my summer for 4 summers and 1 winter. I worked for DelDOT, and we put up signs. If signs got knocked down, we'd fix them. They weren't just stop signs. It was all kinds of signs. But that was my job. That's what helped me put me through college, was working for DelDOT. It was a good job. And people would tell us if a sign was knocked down, we'd go out and we'd go and fix the sign, or we'd put up a new one or whatever. All right? So I worked with stop signs all the time. I never did measure the angles of the stop signs, but if I would have thought about it, maybe I would have. I'm a geek that way. So anyway, let's do this. No, they're not. Let's take a look at this. Find the length of each side. So this is a rhombus. They tell you it's a rhombus. What do I know about all 4 sides of a rhombus? They're all the same. Exactly. They're all equal to each other. So what do I know about this side and this side? If this is a rhombus, all the sides are equal. Don't add them. I don't add them. What do we know about all 4 sides? They're the same, right? They're exactly the same. They are what to each other? They are equal to each other. So if this is the length of this side and this is the length of this side, what's true about the 2 lengths? They are equal. So what am I going to do to these 2 things? Set them what? Set them equal. That's right. I don't add them up. I don't add them up, set them up equal to anything, okay? I just set them equal to each other. So I'm going to go, whatever x is, I always take the larger x, put it first. It just looks a little nicer that way. So watch, I take 3x minus 9 and I set it equal to 2x minus 4. And now we just solve for x, but what does the question say? Find the what? The length of each side. Once I solve for x, what do I have to do? Plug it back in, okay? So let's do this. We've done this, I said this I think yesterday. I think we've done this dozens and dozens, maybe hundreds of times, I don't know. So we subtracted 2x from both sides. I know we did this yesterday. Something very similar to this. Subtract 2x from both sides. Let's take that 9 and put it over to the right side in the same step. So I put a plus 9 and a plus 9. That 2x cancels. Those 9s cancel. What do I have? 3x minus 2x is 1x equals negative 4 plus 9 is 5. It's not my answer. Don't circle it. I'm trying to find the length of each side. So really, they're all the same, aren't they? So it doesn't matter which one I put it in. Which one do you think would be a little bit easier to plug back in? Probably the 2x minus 4. So let's take that x and put it in for this. So it's 2 times what? 5, because x is 5, minus 4. 2 times 5 is 10, minus 4 is what? 6. So what's the length of all 4 of these sides? 6. So EF right there. See, it says, what's EF? Doesn't matter which side they ask you, does it? All right? They could have asked you FG, GH, EH. It doesn't matter. All 4 of those sides are exactly the same. How do I know that all 4 of those sides are exactly the same? Because they told us it was a what? It was a rhombus. And what do we know about a rhombus? All 4 sides are equal. Okay, enough of that. This is an isosceles trapezoid. Yes. It's right there. 6. It's in the blank. All right? Look at this one. This is an isosceles trapezoid. What does that mean if it's isosceles? We just talked about trapezoids not that long ago. That means that this side is what? Equal to this side. Okay? And what are we trying to find? We're trying to find JK. We're trying to find this length right here. This is very, very similar to what we just did. Almost identical. So if these two sides are equal to each other, what am I going to do? Set them equal to each other. Exactly right. So what am I going to write? 2p what? Plus 14 equals p plus 11. And now I solve for p. Once I solve for p, then I plug it back in, find the length of that side. JK is that side right there. And then I've got my answer. It's as easy as that. Super easy. Every single person in here should be able to do this. If you're watching, if you're paying attention, you'll be able to do this. So let's solve for p. So subtract from both sides. Get rid of the 14, so I subtract that 14 from both sides. And 2p minus 1p is p equals, that cancels. What's that? 11 minus 14. That's negative 3, isn't it? It's not my answer, though, is it? I'm trying to find this length right here. So I'm going to plug it in for this. So let's plug it in. 2 times what? Negative 3 plus 14. 2 times negative 3 is negative 6 plus 14, and that is 8. So what does that mean? That means the length of this side right here is how much? It's 8, and that's JK. That's what they're asking for. So it's 8. That's the length of that side right there. Okay? We're almost halfway done. And so far, it's been pretty easy, hasn't it? Don't you wish I would have given you this quiz now? Okay. Let's do this one. It's a little different. This time we're finding an angle. We're trying to find angle P. Trying to find that angle right there. I can actually look at this without doing any math whatsoever and come up with the answer. Look, if these two are perpendicular to each other, what's true about this line on top, OP and NQ? If these are perpendicular, we know that this side is what? Parallel to this side. Okay, now you could do some math to find this answer, but if you know that these are parallel and you know stuff about parallel lines cut by transversal, you should be able to do it without knowing any math at all. Okay, you got to know some geometry, but without doing any math. Anybody have any idea? 60? Why is that 60? Well, this angle would be 60. Okay, right here. Is this angle and this angle equal to each other? There's no way. Look, that's acute, right? Everybody see that? That's obtuse. Any way that those two are the same? No. So that's not 60. Now, you could do this. Now you got 3 angles, don't you? You got a 90 and a 90, which is what? 180 plus a 60, which is what? 240. All right? Take that away from 360 and you get what? 120. That's too hard. It's not hard, but it's too much to do when you don't have to do all that stuff. I can just look at it and tell. Do you remember this? We did a lot of this back in the day. Back in the day. Look, you remember this? And if this was 120 right here, remember if these were parallel lines, cut by transversal? Is this coming back to anybody? Yeah. All right, we did a lot of this stuff. So if this is 120, where's angle P, by the way? That would be, yes, very good. They're alternate interior angles. So if you looked at it and recognized, wait a minute, that's parallel to this, that's my transversal, look at this angle and look at this angle, what are they? They're alternate interior angles. What's angle P? 120, because alternate interior angles are equal to each other. That's the easiest way to do that one. Could you have done it the other way? Found this angle, 60? Yeah. Add them up, take them away from 360? Yeah, you could have done that. You'd still get the same exact answer. What's easier? Just recognizing they're alternate interior angles, isn't it? Yeah. But you got to recognize it. You got to know. All right. We just talked about adding those four up and they equal 360. Well, look at number 6. We want to find angle Q. Angle Q is this one right there. That's what we're trying to find. What do I know about all these angles? We just talked about it like 5 seconds ago. I just mentioned it. What do they do? What's true about angle P, angle O, angle N, and angle Q? What do all four of those angles, they add up to what? 360, right? Because there's 4, right? 4 sides. They add up to 360. You see it or not? Okay, all 4 angles add up to 360. So guess what we're going to do with all 4 of those? We're going to add them up and then do what to them? Set them equal to 360. Is anybody here today? We seem pretty dead today. This is relatively easy stuff. I'm not getting many. Maybe you just know it and you're just not saying the answer. Maybe that's the possibility. But if I ask a question, help me out a little bit and give me some answers. So I'm going to add these up, set them equal to 360. So let's do that. It doesn't matter what order you add them up. Let's go for like the biggest one first, the 3x. Let's do that first. So 3x minus 10 plus either one of these. Let's do the 2x plus 12 plus the 2x minus 2 plus what else? The 2x. And what do they all add up to be? 360. Okay? And now what we have to do is we got to solve for x. Now, it looks impossible, doesn't it? With you guys have your heads on the desk? Look, I'm telling you, this stuff is going to be on the test on Monday, all right? And if you're not paying attention and you see this exact problem on the test on Monday, don't even begin to ask me about how to do it because you're not doing what you're supposed to be doing right now. So everybody's head should be up. Everybody should be watching. Let's add some like terms. Let's add up all the x's. See if we can do that. So I got, there's an x, and there's an x. Let's add those up. Oh, there's another one right there. So I got 3 plus 2 is what? 5 plus 2 is 7 plus 2 is 9. 9x. So I'm done with the x's. Let's add up the regular numbers. Negative 10 plus 12. That's 2. 2 minus 2 is 0. All right, so 9x. So all my numbers just cancel out. So 9x equals what? 360. Divide by 9. X is 40. If you need a calculator, use your calculator. But you should be able to do that in your head. 36 divided by 9 is 4. Put the 0 on there. X is 40. Is that my answer, though? No. They asked for angle Q. So angle Q is 2x minus 2. 2x minus 2. So what do? Put the x. Plug it in, right? 2 times 40 minus what? 2. 2 times 40 is 80 minus 2 is 78. And it's 78. I even put the degree thing there, okay? 78 degrees. It's really not that hard, okay? You just have to know to add up all 4 angles, set them equal to 360, and from there on out, it's just basic algebra. All right, let's do another one. ADC, where is that? ADC. DC. That's this one right there. So what should I do? Let's do this. Let's find this angle. You're like, well, why, Mr. Hammer, why are you finding that angle right there? Well, you got to find it anyway, don't you? You got to find it anyway because it's ABD. But that's going to help us. Actually, you could find this angle without finding ABD. Do you know how? Look at these two angles right here. This one and this one. By the way, they tell you it's a what? What's that little symbol? What's that look like? It's a what? Parallelogram, right. This is a parallelogram, okay? What do you know about the two angles that are next to each other? Not the opposite ones. The opposite ones are equal, okay? But what about the ones that are next to each other? This angle, this big angle A and this big angle D. What do you know? Are they equal to each other? That's always a possibility, right? But look at it. Does that look like 48 degrees? No. And don't go by what it looks like. But look, that's acute. This is obtuse. There's no way they're equal to each other. So what do you think is the other option then? They're supplementary. That's right. So let's do this. Let's find big angle D right there. That's ADC. Let's find it. One little step. 180 what? Minus 48. And that's 132. Yep. So that big angle right there is 132. That's what this angle is right there. 132. All right, so what did you have to know? Excuse me. You had to know on a parallelogram the consecutive angles are supplementary. Okay, we've talked about that on many occasions, not just that one, just not with this one problem. All right, what else do they ask for? ABD, where's that? That's this one right here. Okay. Now, if this whole big angle is 132, what's this whole big angle right there? That's also 132. So how do I find, I shouldn't have put two arcs there. Let's put three of them. Okay. What about this little angle right here? How, if I know the whole thing is 132 and I know this is 55, how do I find this angle right here? From 132, that's right. So I'm going to go 132 minus 55. And that would be what? 77. All right? And that's what that angle is, 77 degrees. So that was a little harder than the stuff that we did earlier, okay? But it was really, stuff that we've talked about for quite a while now. All right? You know the whole big angle? How did I know that whole big angle was 132? Did I just pull that out of the blue? Now, what do I know about opposite angles on a parallelogram? They're the same. They're equal to each other. Exactly. All right? So if this is 132, which I found here, then that whole big angle is 132. Take the 55 away from the big angle, and you got what's left over. Okay? And what's left over is angle ABD, 77 degrees. So this would be 77 degrees. Write it down, okay, if you don't understand. Watch the videos that I first taught it. I probably did something very similar to this with an example or something like that. Okay? All right, two more and we'll be done. Let's take a look at this. Again, this is a parallelogram. Now, this has nothing to do with angles. This is just the sides. So what do I know about the sides of the parallelogram? What do I know about KL and JM? If the top was 6, talk to me, then the bottom is what? 6. Everybody got that? We may or may not use that. I don't know. They tell you something else too, don't they? Sorry, I can't. I need a drink of water or something. All right. They also tell you, they tell you that JL is 6. Where's JL? JL. I used to teach a girl named JL. That whole thing, how long is that whole thing right there from J to L? It's what? What do they tell you? Look, it's right there. It's 6. They tell you it's 6. All right? So they tell you that's 6 as well. You got it? So the top and the bottom are 6, and so is this diagonal right here. Yes? What do I know about the diagonals of a parallelogram? They bisect each other. They're not equal to each other, but they bisect each other. All right? So look at what they want you to find. They want you to find NL. Where's NL? From there to there. So if this whole thing from J to L is 6, what is it from N to L? It's 3. It's just half of it because it's split in half. Bisect means splits it in half. So if the whole thing is 6, that little bit right there is 3. So boom, easy. 6 minus 3. Or I should say half of 6, okay? Half of 6 is 3. What about Km? Let's find Km. Let's do this in a different color. Km is that whole thing right there. That's what you're trying to find. You're trying to find that whole thing. Well, what do you know about this? Well, you know this little bit right here is how much? No? N to M is 3.8. What is it then from K to N? It's 3.8. That's right. So that's got to be 3.8. So what's the whole thing from K all the way down to M? 3.8 what? Times 2. Right. 3.8 times 2. Or you could say 3.8 plus 3.8, right? To get the whole thing. And let's do it. So it's 2 times 3.8, and that, I believe, is 7.6. All right? So there you go, 7.6. This is all in millimeters. I wouldn't mark it wrong if you did not put millimeters, but you should. And there you go. There's the quiz. We worked through it together. You got it. Even though you didn't take the quiz, now you know it. That stuff that we just talked about is going to be on the test. We have 5 minutes. I doubt we'll be able to get through this, but let's just talk about it really quick. I probably won't do every single problem, but let's take a look. Let's just set them up, all right? Then I'll let you do the math on them. So it says find the value, find x and y, all right? You just took this quiz not that long ago. Agreed? Was it this week? Monday or something like that? I think you just took it. So what do I know? How do I solve for x? What do I know about this one and this one? They're equal. That's right, because it's a parallelogram. So how do I set it up? 7x minus 24 equals 3x. You do the work. You do the math. All right, and I'll give you the answers, though. So x is 6. All right. How do you find y? Well, look at this. These two right here. Do you see those two? They're across from each other, so what's true about those? They're equal. So how do you set that up? 7y equals 2y plus 5. And then once you do that math, you get a 1. Right? You do the math. What about here? What's true about the diagonals of a parallelogram? What do? They bisect each other. So what's true about this one and this one? They're equal to each other. You write it down. Set them equal to each other, solve for B. What do we know about this one right here and this one right here? They're equal to each other. So what do? You set them equal to each other, you solve for A. You would have gotten a 4 here and a 3 here when you do the math. I don't believe on this one you had to do the substitution. Remember that one? Okay, and we did go over that after you took the quiz with the substitution. I will double check to make sure that you don't have one of those on the test, okay? So, and if I did put it on the test, maybe I'll just give it to you for free, all right? I don't know if I have it on there. I just don't want to go through the effort of making up a brand new test just to not put substitution on there, all right? But anyway, we discussed 3 and 4 a lot the other day. So what about this one? The length of the rectangle. What do find each length? QS. Where's QS? That's that diagonal. Now, this is a rectangle. What do we know about the diagonals of a rectangle? They do bisect each other, but they do something else. They're equal to each other. Exactly right. So look, QS is equal to what? PR. And I know what PR is. That's 12. So QS has got to be the same thing. So without any math at all, you just put 12. What about this one? They tell you that QT is 5. All right, from Q to T is 5 on this one, number 6. What is PR? P to R. Well, if this is 5, that's 5, right? Both diagonals are the same, so PR is also 10, right? SQ would be 10, PR would be 10, and there you go. It's 10. Whoops, that's a weird looking 10. There you go. Super easy. What about this one? Angle 1. Well, we already talked about it today. It's a rectangle, so this and this are parallel. There's your transversal. Look, Look at angle 1 and 35. They're alternate interior angles. So angle 1 is what? 35 degrees without doing any math. Wasn't that nice? Angle 3 is a little bit tougher. Not that bad. Now watch. This triangle right here, these two sides are equal, so that means the opposite angles are equal. So that means that's 35. How do I find this angle right here? This angle right there. Add them up, which is 70. Take it away from 180. What's 180 minus 70? It's 110. What is angle 3 to this 110? They're equal because they're vertical angles. So what's angle 3? 110. Easy. Okay? 2 more and we're done. And this is the tests. Angle EFG. EFG. This whole angle. That's what I want to find right there. Okay? It is a rhombus. So what do I know about the diagonals on a rhombus? What do they do to each other? They bisect each other. So that's 60. What do I know about these angles right here? Now, these two angles aren't equal. What are they? We talked about this earlier. Look, that's an obtuse angle. That's an acute angle. There's no way they're equal. They're supplementary. So if this is 120, right, what's this whole big angle? 180 what? Minus 120. What's 180 minus 120? It's 60. So that whole big angle is 60 degrees. That's what they're asking for, isn't it? That whole big angle. So that would be 60 degrees. What about angle 4? Well, let me do this. If that whole big angle is 60, what's this little tiny angle right there? 30. And what's this little one? 30. These angles are equal to each other. So what's angle 4? That's 30, right? And that's 30, right? So angle 4 is 30. A lot of people got this one wrong, these two wrong. Okay, I'm not sure what you're looking at. Maybe you made these two equal to each other or something. I think people did make those equal to each other. That's how you do it. Look, there you go. You got 4 sections. So the test is going to be 6, 1, 2, 3, 4, 5. We went through 1 through 4 today. I said we weren't going to review 5 because we did it yesterday. So that's going to be on Monday. So the test, the Chapter 6 test, the test is on Monday. Yeah, I'll post it today. All right, there you go. Okay, thanks. Just put it right there. Thank you.